This video will have a few examples regarding parabolas. The first example is find the vertex, focus, and directrix of the parabola y equals 1/16 x squared. The first thing that you should notice is that this is of the form x squared equals 4py. This is one of the forms of our parabola, and it's the one with the x squared. So let's try to take this equation and solve for the x squared, and we'll do that by multiplying both sides by 16. So we have 16y equals x squared, or just switching it around, x squared equals 16y. The next thing that you should notice is that the coefficient of the y, which is 16 in this case, represents the 4p. So if 16 equals 4p, then p is equal to 4. So this is a distance from the vertex to the focus, and also from the vertex to the directrix. Because it's positive and we have an x squared, we're going to have a parabola that opens up. And we know the vertex of the parabola is 0, 0. You can test that by plugging 0 in. And we're going to plot just a couple points. Let's just see what happens if I plug in x is 1. I should get 1/16, really small, really wide parabola, like this. Okay, so what we know is 4 units inside the parabola at 0, 4, we have a vertex, and 4 units behind the parabola, we have the directrix, which crosses the y-axis at -4, and then our vertex, of course, is 0, 0. So our vertex is 0, 0, our focus is 0, 4, and our directrix is y equals -4. Remember that your directrix should be an equation. For our next example, we want to find the standard form of the parabola, x squared minus 6x minus 3 minus 12y equals 0. So the first thing we're going to do is write down what our standard form is, which is x minus h squared equals 4p y minus k. This will be a parabola. Notice the x is squared. So depending on if p is positive or negative, it will open up or down respectively. And our vertex is going to be hk. So we're going to start this process by moving the 3 and the 12y to the other side. So we'll have x squared minus 6x. I'm going to leave a little blank here because we're about to add some, which is going to give us on the right-hand side 12y plus 3. Now, what we want to do is create a perfect square trinomial on this side of the equation. And the way that we do that is we take half of the middle term and we square it. So in this particular case, half of -6 is -3, and squared is going to give us 9. So we are going to add 9 to each side of this equation. So on the right-hand side, we get 12y plus 12. On the left, the whole reason we created a perfect square trinomial is we want this to factor. And we shouldn't have to think too hard because this value here is always going to be the half before you square it. So now we have x minus 3 squared equals 12y plus 2. So on the left, we do have this part, but on the right, we want to have the coefficient of the y being 1. And so to do that, we will divide or factor out the 12 and get y plus 1. So in this particular case, our vertex is 3, -1. This 12 plays the part of 4p, so our distance between the focus and the vertex and the directrix is going to be 3 units. And since this is positive, our parabola is going to open up. So let me see if we can do this. 1, 2, 3, minus 1. There's our vertex. And we know it's going to open up. And 3 units above, so 1, 2, 3, we will have our focus of 3, 2. And 3 units below, 1, 2, 3, we will have our directrix at y equals -4, and then our parabola, I'm not exactly sure where it crosses the y-axis, but just as a sketch, we'll get something like this. Now, if I wanted to know the y-intercept, I would just let x equal 0.